the arrows for myself to help me so that when I started writing the words out, I wouldn't get those backwards. Okay. Checkpoint 2 wants us again to determine the end behavior, but this time of f of x equal to 2x to the third times x minus 1 times x plus 5. Now, where is my leading term? No. Remember, for it to be a leading term, I have to have it so that it's in the form of some number times x to a power plus or minus some number times x to a power plus or minus some number times x to a power. Is this in the right form? One thing I could do is I could like multiply it all out. Do I really want to do that though? No. What am I going to be doing? I'm going to be multiplying these together, right? So, number 1, on all of these terms here that are the leading terms, that's a 2, a 1, and a 1. So when I multiply that together, a sub n is 2, right? Everybody get that? I just took the numbers here in front of the x's, because that's going to give me my leading term, right? Multiply it all together. Now I need to know if n is even or odd. How did you get that? What's the degree of this one? 3. What's the degree of this one? And what's the degree of this one? When I multiply exponents, when I multiply like bases that have exponents, what do I do to their exponents? I'm adding them up. So n is 5. So it is odd. Very good. Okay? So just knowing that without having to go through and multiply all that junk together, what do I know about this end behavior? It's positive, n is odd, and a sub n is greater than 0, so it starts down but ends up. Okay? So that falls to the left, rises to the right. Okay? You do need to memorize those 4 sets. What? Up and up? Where'd it go? There it is. No, because one's got to face left and one's got to face right. So they're never going to go the same direction. I understand what you're asking me now. Sorry. All right, and checkpoint 3, the last example of this in behavior. They want us to find the end behavior of f of x equals negative 0.27 x to the third plus 9.2 x squared minus 102.9 x plus 400. But remember, what am I looking at? If I'm wanting the end behavior, I'm just looking at the leading term. So is this exponent even or odd? So it's odd. And is my coefficient that goes with that one with the highest exponent, is it less than or greater than 0? Less than 0. So you look back at your little chart that I gave you, and you'll see that that means that it rises to the left, falls to the right. Okay? So don't let that throw you off just because it gives you ugly numbers. Remember, if I'm wanting to know about end behavior, all I need to know is what's the degree, is it even or odd, and what's the coefficient. Okay? Any questions? That's not multiplied. That's added. The reason I added up here is because these were multiplied together. Okay? Good question. Now, get your graphing calculators out. In y equals, I want you to type in x to the third plus 13x squared plus 10x minus 4. Oh, darn it. Yeah. Gotta press what? Now delete's gonna push me down. Okay, thank you. Plus 13x. Anyway, type it into your calculator. Go to the Zoom and go to standard window and hit enter. And look at your picture. Okay. Now, I want you to look at that equation. F of x, this is checkpoint 4 by the way, f of x is equal to x to the third plus 13x squared plus 10x minus 4. Tell me what the end behavior ought to be. It's odd and positive. It ought to start down and end up, right? Does your picture on your graph start down? Does it fall to the left and rise to the right? So do you have a complete graph? No. Okay? That's what I'm telling you. I know your calculator will graph these for you, but sometimes you don't have the window big enough where you can see all of the graph. So that's why you need to memorize this, and you need to know what the end behavior needs to be so you can see if you've gone far enough out that you can see everything in the middle that you need to see. Okay? All right. Now there's another piece that goes with that. There's some more pieces that go with that. The next thing that we talk about is being able to find the zeros of the function. What does zero mean? Okay? The intercepts. But it's the x-axis, the x-intercepts that we're talking about. When we talk about zeros of the functions, that's where the function value is 0, which are the x-intercepts. Okay? So if you have an equation or a function, f of x is equal to x to the third plus 2x squared minus 4x minus 8. Then to find the zeros of the function, what that says is I'm going to say 0 is equal to this. You just spent a lot of time in Chapter 2 learning how to solve this equation. What do? It's called factoring by grouping. Remember, if there are 4 terms, factor it by grouping. There's an x squared that's in common here. That leaves the x plus 2. There's a negative 4 that's in common here. That leaves x plus 2. Then once you factored the first time, you turn it into 2 terms that also contain a common factor of x plus 2. So I can factor those up front. And I get left x squared minus 4. And I'm hoping that you recognize that x squared minus 4 is the difference of 2 squares. So that turns into x plus 2 and x minus 2. Right? And so my zeros, the places where it's going to cross the x-axis is when x is equal to negative 2, when x is equal to negative 2, and when x is equal to a positive 2. Now, did you notice that I have the same x twice? Okay? That's something called multiplicity. Objective 5 deals with multiplicity of zeros. That actually means something to my graph. If a zero appears more than once, then it's got a multiplicity. So this one has multiplicity 2 because it's there twice. This one's got a multiplicity of 1 because it's just there once. Okay? Now, the way multiplicity works and how it has to do with my graph is that zeros with even multiplicity. So again, 2, 4. Touch the x-axis and bounce off. In other words, so if it's above the x-axis, it'll come down, it'll touch the x-axis at that point at negative 2, and it will bounce off and go back up. It does not cross through it. Zeros with odd multiplicities cross through the x-axis. Okay? That's kind of an important idea because it gives me an idea of the shape of the graph. So what this says to me is that I'm going to take, at x equals negative 2, I'm going to bounce off the graph, but when x is positive 2, I'm actually going to pass through it. Everybody understand? Okay. Objective 6. Oh, well, let me do objective 7.